In this video, we are simply discuss about the concept, that is the mathematics behind the Naïve base, and in next video we are discuss about its geometry interpretations with some example. So now let's see how it is mathematically interpreted and why with this theorem we call the Naïve base theorem. The simple behind to rename this theorem, this classifier theorem, as Naïve base theorem, because here just we are using the concept of Bayes theorem that we are learned in previous lecture. Okay, simple because we are calling this theorem Naïve and base. First learn why we call Naïve and base because we are simply using here Bayes theorem, that is already we have discussed in previous lecture. Because of we are using here Bayes theorem, and we call this theorem Naïve because Naïve means unsophisticated algorithm. This algorithm is unsophisticated algorithm and it is simplistic algorithm. Because of these two things, we call this theorem as Naïve based algorithm. Because why? This theorem is unsophisticated. Unsophisticated as well as it is a simplistic algorithm. Because of these two logic, we have already called this name. And also there have another reason where we'll discuss its the conditions and mathematical some formulations. Then we have seen why the main reason we call this name and why the logic behind it. But because simple, just see, because of simple its unsophistications and its simple simplifications, we call this theorem as Naïve base algorithm. Okay, simple. Now the thing is that we have discussed this algorithm by using simple Wikipedia link. Okay, just simple type on Google Naïve base classifier wiki. Just you can easily find the classifier algorithm. Okay, now let's go there. So first let's take our data point is, suppose let's take x is our data point, that is already given here, and also I am writing we have given data point that is x, and also we in generally we have taken for a data point d features, but as we are just going to parallel to the Wikipedia, so simple also here we are taking that our data point has n number of features. Okay, that's just the x now will be lying on the n dimensional space. So let's take our data point will be like this, that is x1 x2 x3, just simple dot up to xn. Just let's take our data point is lie on n dimensional space because of we have n number of features. Simple, we have n number of features, and this thing actually we are interested to find this probability. Now what is the meaning? Just if you just remember the probability distributions, what is this meaning? This is if you just simply write this thing in that way. What is this meaning of this probability? First let's see what is the meaning of this probability. This probability is nothing. This probability is simply we have to find the probability of the class level k for a given point, that is x. Okay, this means that. So just write down what is the just English meaning of this notation. So the English meaning is probability of the one thing we have just mistakes here. Actually we have also another thing here. We have the class level, that is ck. Actually for here we are k class level. The given data sets, if we have simple k class levels, then our class levels, let's take our first class level is c1, second c2 up to we have class level ck. Okay, and if our simple if k is equals to 2, then what will be the class level here? The class level in this case will be 2. So in such cases we need a binary classifier binary classifier. But here actually we are using this thing because of simple we are constructing here multi-class classifier. Okay, so be simple we are using k is equals to simple, here using this one because we are using the multi-class classifier, and here we are for our assumptions our class level is given, class level is number of k, so class level equals to k. So simple for this here we are using. So this means what? Actually this means probability of a class level k, if they have I, then simple probability of a class level I, so simple because here we are using ck, so probability of a class level k, class level k for a given point, that is x, for a given point x. So this simple, the English meaning of this notations is like this one. Okay, I think we have already learned this thing in when we just revisit the conditional probability classes, then you can easily find this one. So just now here as we are simple here using the Bayes theorem, just see this one. And now if you ask why we are just find this conditional probability, why it is need us, actually because what is the actually our main target we have to, for a given query point, just if we have a given query point we have to find its class level, that is called yq, and yq simple belongs to of any one of these classes, because here we have taken the k class levels, so our query output classes of our query point will be any one of these classes. Now simple we are interested to find the class level of probability of the all class level, because here we are interested to find what, we are interested to find the class level for the given point xq, we are interested to find the class level for the given point xq, sim dot up to we are interested to find the class level, that is ck, for the given class level xq. Okay, we are just interested to find these classes, and among these classes which probability the maximum probability we are taking a final class level. Suppose let's take our maximum probability is this one. Suppose let's take this one is the maximum among all the k classes, among all the k probabilities, this one is the max. So finally we have decided that our class level is, that is our xq belongs to xq, the class level of xq will be c2. Okay, so simple class level of the xq will be c2. Just because of this thing we are simple calculated this conditional probability. Okay, now I think you are already understand why this one is so important, why we are calculating this thing. Okay, now let's come to the next step. Now simple this thing means just I'm using another color. Okay, so this thing means what? This thing means simple probability of ck given a point. This is simple for a given point x. Just here we are using this symbol, and here we are using nothing, just we are using the Bayes theorem here. Just if you remember what is our actually Bayes theorem, probability of a for a given b, probability of a for a given b. What is the Bayes theorem? Here just apply the Bayes theorem. So Bayes theorem will be probability of b, and our probability of b simple not is equals to 0, and probability of our numerator term will be probability of b for given a into probability of a. This is the simple Bayes theorem. Just we are applying this Bayes theorem here. Nothing else. Okay, now we are just interested to find the P1k, P2k, P3k, and at last we have to compare this one, which one is the largest one. And if you just see the px is the largest one. Px is the constant. Simple, px is the constant one here. Px is the constant, because px here same for all probability. We have to, that is actually at the end of the day we are interested to compare this value c1x, c2x, dot 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 up to cax. We are compare these k values, and we have seen the for h probability in denominator we have already p of x, and p of x is the constant. P of x is a fixed value and it is appear for all of one. So simple, we just omit this thing, we are just neglect this thing. Okay, for comparing purposes we have just neglect this one. And if we have neglect this one, then what will be the value of this thing? Actually this thing now will be is simple proportional to p of ck, p of x for given ck. Actually we are we just avoid this thing, p of x denominator term. So this thing will be simple proportional to the numerator term. I think this concept is okay, and this will happen for all k. Just if we have taken, we have to, our class level is capital K. Okay, and just simple small k is our script. So our small k will be now 1 2 dot dot dot, dot up to class capital K. Okay, I think this thing is clear. And also when we are just learn the Bayes theorem, then then I call that this theorem, the mathematicians or statisticians, this theorem is called the posterior term. This theorem, this term is called the posterior term. This term called the prior term. Prior term. This term called is the likelihood term, and the denominator term is called the evidence term. Okay, just simple, just using this thing as if you just interested, then remember it, unless it is not necessary. So that now simple, just our, now the main thing is our numerator term. Okay, now just see the numerator term. So let's see now the numerator term. Okay, this term. Now our important thing is this term. Okay, just see this thing. If you see this thing, this simple thing means what? This simple thing means probability of ck comma x, or as well you can call this one ck intersect of x. Means what? Actually this is the explanations of the conditional probability of this one. Probability of the point x for a given class level ck. This is the means of, if you just use the definitions of the conditional probability here, then what will be this thing? Probability of x intersection ck divided by probability of ck. If our probability of class level ck is not equals to 0, because we assume that for our class k there have some point. Okay, we are assuming that this thing, if these are not equals to, then we can write this thing. And now simple, we are multiply. If you just multiply this thing this side, and simple we got that this term, we are simple got this numerator term, and simple we are just writing this thing as this one. Okay, I think now, and because of we are using the combined probability ck intersect of c1, so because of we are using this is combined form, so simple another language we called is the joint probability model. In another language, this thing is called the joint probability model. Okay, I think now clear. So simple, this term, now we are interested to calculate this term only. Okay, this term means this one, both things are equivalent. We are avoiding our denominator term, we are not interested. we are just interested in, and simple, this term is this one, the joint probability model, if you just call. So now we are just simply interested this term. If you just in another, just I think, sorry, okay, if you just write this term in this formula, P of Ck in the term of capital X, we are simple use writing this one, that is x1 x2 up to xn. We are simple writing this one. So this thing means we are now simple, we are interested to calculate this thing. Okay, I think now this up to this term you are all about clear. Now the main calculations and main assumption part and the main thing is happening here. We are simple, if we are simple calculated this term, then our work is done, and nothing has done, nothing we have to do here, just we have to calculate this term. So now the main matter is how to calculate this one. So it is simple. So how we calculated this one, just if you if you see this thing, let's use the another color. Let's see, it is our event A and it is our event B. This one is event B. Okay, let's take this is simple, our event A, and this total thing is event B. This is means what, this one, and in another, just don't forget about this one, and we can easily write this thing x comma ck, because we have seen that inside theory A intersection B is equals to simple B intersection A, and we see this one, and easily we can see write this one x intersection ck, and this one simply x. Both are the same thing. Okay, if these both are the same thing, so instead of just right now just using the simple chain rule, we are using a simple the chain rule. Okay, and related application to definitions of the conditional probability, simple, we are using this one. Now let's go to the how we are using the chain rule in probability. Okay, now just go to our notepad, then simple we are calculated there. So what we will get from our Wikipedia page, we are simple get that we are interested to calculate it probability of x1 x2, probability of x3, probability of xn, and probability of the class level, that is ck. We are simple interested, and this term is simple our coming from our x term, x point, and this is our simple class level. Okay, we have seen this one. Now we are just if you just assume this thing, if you just simple we are assume this thing, this is our simple one event A, and the rest of the thing is our, let's take it is our another event, let's take B. Okay, let's take this simple x1. This x1 means what, x1 x2 x3 up to xn means what, this is x1 is for our responsible our features 1, this is responsible for features 2, and simple this xn is responsible features n for the data point x. Okay, now we are simple just using the definition of the conditional probability here. This will occur here. Now we are simple using the conditional probability here. So what will be the definitions of the conditional probability? Now the conditional definitions of the here conditional probability will be, so A given B of probability B, simple this one means this one is the definitions of conditional probability. Nothing else, just now put down this thing here. So now what will be the A is simply x1 of given B, B means x2 x3, just write okay, no problem, just write, just continue with flow, xn, that is xn comma c, okay, into probability of B means x2, x3, xn, ck. This one simple, just definitions. Here we are simply apply the definitions of the what conditional probability. Now we are interested simple. Now here we are interested to calculate this term, this formula, because we are telling that we are interested to calculate the chain rule. So actually we have to calculate this probability. From this probability we get this probability. Now we have to calculate this one. Now how we will calculate it? Just same thing we are also apply here. So how? Let's see. So now similarly we are calling this x2, because this probability starting from x2. Simple, the first point we are taking B, and the rest of the point we are simple as previous. We are simple, this thing is calling C. Let's take. Now what will be this thing? Probability of B with condition C, as well condition C. So I think now this thing will be x2 with given C, x3, x4, xn, ck with probability C. Probability C means what? Probability C means x3, x4 up to xn up to ck. And as well here also we have this term. So I just calculated this thing here. Okay, now the final term will be what? So if you just think the final term, now the final term will be what? So let's see. The final one will be now x1 with conditions x2, x3 up to xn, ck. Now this one means this thing into x2 with given x3, ck into probability of x3, x4 xn, ck. Now I think you understand this thing. Now similar, the same process will be happen for this probability as well. I think how the chain rule works you will understand. So I think this again it is not required to repeat this thing. Okay, now let's go to the Wikipedia page. What happened there? Okay, so just see, we calculated this thing. Just if you just remember the notepad, we are calculated this one, and also from this one we are calculated this thing up to this one. Yes, we have calculated this one, we have just calculated up to this one. If we just repeating the same thing, now at the final stage we are simple come on to this one. So probability of x1 given x2 dot to c keep x2 dot to cn. So up to the end we go after end we got this one, probability of ck. So after that, before we have reached this probability, after this before we have reached this probability. Simple, we have just using the simple chain rule, that is in iterative process. So after final stage you got this step. Now the main thing is how to calculate this probability, this conditional probability. This is the main tricky part in the Naïve based classifier. This thing is the main tricky part. So let's see how we will calculate this one. Okay, so let's take. So before I think before calculated, if you just discuss one example using this one, I think then it will be better for you to understand. So let's take an example for this one. So suppose we want to interest group build a classifier for these classes. So let's take our classes, these three classes. We have three classes. So our class is, suppose we are interested to find the class level is obs, and it is a human. For a human health, we are just interested to calculate the human health, though a man or woman is obese or fit or it is lean. We are interested to find this one classes, and our features will be like this. So our features vector is what, first. So if you just want, we have features. First features is equals to weight. Second feature, simple, we have the second features that is equals to hair color. Hair color. Third features is equals to our, suppose let's say, hair length. We are simple, in short we are using hair color. It will be some characteristic value here. This one, weight is a real number, real features, real valued features. Hair length, that is also a real valued features. It is a categorical features. Simple, this one is a categorical features. And one another features that is equals to hair eye color. Simple, what the eye color. Okay, and simple, it is also a categorical features. So if you just see one point, and now if you just see, so here actually 4 features. So our point will be like this one, x1, x2, x3, x4. Okay, this type of point we have actually. Suppose let's take we have a point like this. We want to interest to calculate it, this probability. Suppose let's take our point is this one. Our sample, this point is our, suppose let's our weight is equals to sample, just using the normal vector here, this kind of. Okay, we have actually our weight is equals to let 180 centimeter. Let our hair color, it's just a simple hair color using hair color. Let's take our hair color is black. Our, let's take hair length is equals to, let's take up suppose 5 centimeter. And eye color, let's take our color is brown. Okay, this is our sample A data point. And for this data point, let's take our data point. For this data point, our class level for this point is what? Power point is obvious. Okay, simple, this is our data point. Okay, now we are interested to calculate the probability. For just see now this, just we are interested to calculate this probability. So what this probability means, what? Just I'm using the okay, this color, brown color. We are interested to calculate the probability of x1 means, here x1 means what? Weight. X2 means hair color, x3 means hair length, x4 means eye color. Here we are given our weight equals to 180 of given. We are interested to calculate this probability. Just write down this thing first, then we are just see this thing English in a literature way. Okay, so first just write down in mathematical way, then we are just interested to understand in literature way. So of given h, that is hair color, is equals to, suppose like black, hair length 5 semi, eye color brown, our class level that is, let's take CK, obese. Now we are simple interest to calculate this probability. Okay, we are simple interest to calculate this probability. So this means what? This means we have to calculate it. We have to calculate it, the probability of weight. Simple, we have to calculate the weight of 180 centimeter for given hair color is this one, a height is hair length is this one, eye color is this one, class is weight. a class level is obvious. But the main thing is we have in this probability, just if you see if your data set, just if you see a data set, if you just see a data set, we are simple in this data set, we have to find this kind of data set simply. Just if weight is simple 180 centimeter, our weight is fixed, but our this thing will be vary. Only we have to find this kind, this certain in this, if this is for weight and rest of the thing will be varied. So rest of the 3-4 features will be varied. So it is in really this kind of thing is a unrealistic thing, because if you just see here length is our 5 centimeter and weight is also a real number, so it will dramatically change for it is vary for each person to persons. So for example, we have to interest to find a people whose weight are 1 centimeter and hair color is be black, just each this thing will be same. For a persons we are interested, this thing will be same, okay, but only vary the weight. So this kind of data type only we have just record some few data set, but in really this is never happened, okay, this kind of situation never happened to find the exact data, okay, just we have to find the exact data for this one, for this event, if you just call this event B. So in to avoid this kind of situations, to simple the shortage of this same kind of data, we are using here some assumptions, okay, we are just simple make some assumptions. Now let's take what is the assumptions here. Now let's take simple the assumptions is, okay, so the simple assumptions here, assumption is our conditional dependence, that is our features, the features are mutually independent, okay, this is the main assumptions. And because of this conditional independence, our features are conditional independence, in another language this thing called a naive thing, this thing are naive. And another reason for we call this theorem as naive is because of this reason, because we have using our features, these are both are mutually independent, or mutually independent as well as it is conditionally independence, okay. So here as previous example we are taking our features are, there are 4 features x1 x2 x3, sorry, we have taken the features, that is f1 f2 f3 f4. Simple, these features are mutually independent, means our pair of features fi aj are independent, okay, this thing means that. And also we have seen in the second lecture what is the mathematical formulations of a mutually independent. Suppose if we have two event A and B, if we have two event A and B and a conditional probability A for a given probability B, so these two events are called the mutually independent if this conditional probability will be probability of A. We have seen this thing in the second lecture. Now we are just apply this concept, okay, here we are just apply this concept here, but the main thing is we are only see the independence between two events. So if we have more than two events, then what we doing here? So suppose let's take our event will be like this, probability of A with given B and C. In another language we call this thing is probability of A given B intersection C, okay, B intersection thing, this thing another language we call B intersection C. So this these two events, so actually here A is one event and B intersection C is another event. So this A is now conditional, we have seen here using simple conditional independence. Okay, so here we are call that A is conditionally independent of B for a given C. So this thing, if actually here features is what our features is here, actually if you just compare this thing, for here our features is actually A and B and C is the class level. Just we are compare this thing. So I think it will be, look, first just let's see thing, just compare this thing. A and B are same as your features x1 and x2, and also we have in that end we have given class level, that is CK here. So if you just comparing this thing, that one, so actually features is A and B only, and we are assume that our features are only conditionally independent. Okay, not we are calling the features are independent to our class level. So simple features, between the features it is mutually independent, not it is not independent on our class level. So because of this we are writing this thing, event A is conditionally independent of the event B for given for a given event C, for a given event C. Okay, this thing, if this happen, then this probability will be written as probability of A with condition B, C with condition C, probability of A with given condition C. This thing will be written as like this way. Okay, I think now clear what is the conditional dependence. Since in previous lecture we are in second lecture we have learned already independent. Now you see what is the independence, conditional independence. Now just write this thing in feature equal. I think then it will be clear all of you. So if you just write this thing in this way, probability of x1, let's take x2, x3, x4, because we have 4 features in previous example, and let our class level is about CK. Okay, now we are interested to find the condition. So this thing will be written as, so features 1, so features 1, just f1 is I think spelling is okay, conditionally independent of the features f2, f3, a4 for a given class level CK. If this happen, then this probability will be written as in this form. So this now probability will be written as x1 given class level CK. Okay, this is the main thing. So this thing will be assumed here. Now the naive means conditional independence. Assumption come into the play. Assume that all the features X are mutually independent and condition on the category CK under these assumptions. Okay, because of these assumptions, I think from the example the idea is clear all of you, the what is conditional independent. Okay, I think now let's go to the calculations part of this. Okay, I think now clear. Okay, now this thing, if conditionally independent, if this thing is conditionally independent, so this probability will be written in this form. Okay, from this probability will be in this form, means here actually this xi is, this thing means what is independent of xi plus 1, xi plus 2 dot up to xn or a given class level CK. Okay, this thing means that. nothing else. This thing, simple, this thing means that. Now we are interested to calculate this probability. So which probability we are interested to calculate it? Actually we are at the end of the day we are interested to calculate it. Just if you see the our final thing, just I think okay, just if you see this thing, I think we are interested to calculate this probability. This probability means actually we are interested to calculate a probability of ck and of a point x, and we see we have to compare all for all the classes. These things we have not interest to calculate it. So this thing simple proportional to what? This thing simple proportional to probability of we have seen this one. This thing is simple proportional probability of ck comma x means intersections of x. We have seen this thing and just beginning of this lecture we have seen this thing. Now sample we are using this one here, nothing else. Here if you're interested in calculation, this just writing this thing here, ck of cx1 x2 x3 xn, and we have sample find just before of this pair we are using this one. Just first we have written this term and after that we are writing this one, and we have seen that these all the events are mutually independent. So because of this we are simple calculated, we have written s terms, this term. If this one is mutually independent, this one will be written as x1, some small, it will be small x1 by ck. This term will be written as probability of sample x2 given ck. If this is mutually independent, this term will be written as probability of x n minus 1 given ck, and this is already, and this thing just I am writing the first term here, and just from beginning I am writing here, nothing else. Okay, I think, and up to it will be probability of xn given ck. Okay, just omit this thing. Okay, I think so simple. Now using the notation summation, multiplications here, all the terms are multiplied by. So simple, these multiplications mean I equals to 1 to n xi. This thing means x1 into x2 into x3. We have already learned the summation time, sorry, the multiplications pi, and summations we are using the sigma. Okay, just using the, instead of using here I am using the pi sign for multiplications purpose. So pi, so probability of ck pi of probability of cxi up to this one. Okay, I think now this term, calculation of this term, the calculation, so simple, this is the proportional because we are avoiding the denominator term. So what is the denominator term here? Probability of, just see this first one. So denominator probability of x. So simple, the probability of x we are avoiding here. If you just calculated the probability of x, probability of x, just because of this, if you if it's just z is the value of the probability of x, if simple z is the value of probability of x, by simple we are not interested to find this probability, so it is not required as much. Okay, just omit this term because it is simple we have to calculate it. We are not interested in this term. If this probability will be equal, then we have to add the denominator term, so we have not interested here. Okay, just forget about this term. Now just simple, at the final day we have just for h term we can easily compute this term. For h classes we can easily compute this term. For h classes we can easily compute this term. Now at the final we are interested to calculate it, compare this one. Before comparing, how we'll compare, we have to actually find the maximum of this probability. We have to actually interest to find the maximum probability. So the maximum probability among all this probability. Okay, you see, we are actually interested to compare all this probability, that is probability of C1 given X, probability of C2 given X, sorry, CK, given X. We are interested to count the maximum of all of these one. Because of this, we are simple using here argmax. Simple here using argmax, and we have taken the case running from, if this one is small k, is running from 1 to up to capital class K, because we have capital K number of class levels. So because of this, K is belongs to sample 1 to capital K, or sample just we have using the sample, just I have putting this term here, nothing else. Among this we have to find the maximum one, and this K will be our actual class level of the required point X, of the required point X. I think now the Bayesian theorem is clear, all of you. If you have the confusions of this lecture, please, I request you, please revisit this lecture again, then I think it will be clear. This is not a rocket science. If you just try to understand this thing literally, okay, step by step, then I think it will be clear. Actually, at the end of the day, we have to calculate these values. Probability of class 1 for a given point X, probability of class 2, what will be the probability of the H classes for a given point, and the maximum probability will be the class level of that point. This is the simple trick, nothing else. And how we will see how to calculate this probability by using simple Bayes theorem and definitions of the conditional probability. And simple, we are using Naïve. Naïve means we are using simple the conditional independence. I think using the example that we have taken here in this exercise, in this lecture, I think from this example you are already know what is the conditional independence. Okay, I think all the thing of this lecture is okay, all of you. So if you have any problem, comment below, or I request you, if you have if you don't understand this thing till now, please revisit again. After that, if you have any problem, please comment below, I am here. Okay, so thank you.